This video is a video on the division properties of exponents. In order to divide powers with the same base, we subtract the exponents. If we take a look at the longhand version, which again is not something we're going to do every time, but just to show you where this rule comes from. If we have x to the 6th divided by x to the 2nd, we have the same base x. So I would write that out longhand. It would look like this. X times x times x times x times x times x all over x times x. Well, if we go ahead and use our simplification when we divide any number or any variable by itself, we recognize that this x and this x could cancel each other, and this one. So it leaves us with an x to the 4th. But if we follow the rule that we read up above, keeping the same base and subtracting the exponents, we could get that same answer by saying x to the 6th minus 2, which is x to the 4th. The other property that we're going to look at is raising a quotient to a power. In order to raise a quotient to a power, we take the numerator and the denominator to the same power and then simplify. So again, we're going to take a look at the longhand version, and that would be x over z. That quotient, if we raise the entire quotient to the 4th power, it would look like this. X over z times x over z times x over z times x over z. Again, if we take a look at what that truly means, we have x to the 4th over z to the 4th. If we just follow the rule that we were stated up above, that we raise each, the numerator and denominator, to the same power and then simplify, x, it's almost as if we're distributing this exponent. So it would be like x to the 4th over z to the 4th. Let's take a look at a few more examples that are a bit involved. In this example, we have x to the 4th, y to the negative 1, z to the 8, that product in our numerator, and we're dividing by x to the 4th, y to the negative 5, and z. So when we have an expression like this and we're asked to simplify, we need to remember all of the properties that we've talked about so far. We need to remember properties about negative exponents, about zero exponent, and then our multiplying and our dividing rules. Alright, so we're going to look at the different bases that we have that are the same. And if we split this up, we have x to the 4 minus 4. And then we have y raised to the negative 1 minus a negative 5. And z to the 8 minus 1. Because we recognize that this z in the denominator is really to the 1st power. So now if we go ahead and simplify those subtraction statements up in the exponents, it becomes x to the 0, y to the negative 1 minus a minus, that's saying plus. So negative 1 plus 5 is 4, and z to the 8 minus 1, or 7. Okay, this still isn't in simplest form because we have the 0 exponent. So we can simplify it one more time, and we get 1 times y to the 4th z to the 7th. This is our simplest answer. Another example of a quotient, we have a to the negative 3 times b to the 7th, all divided by a to the 5th, b to the 2nd. So again, we're going to look at our bases that are the same, and that would be the a, and we have a negative 3 minus 5 times the b, 7 minus 2. So that becomes negative 3 minus 5 is a negative 8, and then b to the 7 minus 2, or b to the 5th. This is not in simplest form because we have a negative exponent, so we need to move the a base to the denominator, and we will lose the negative exponent that way. The b to the 5th remains in the numerator. This is our simplest answer. And finally, our example of an entire quotient raised to an exponent. In this case, the exponent is negative. Remember that negative means we're going to take the reciprocal. So I'm going to go ahead and rewrite this as the reciprocal, 5b over a, raised to not the negative second any longer, but to the second power. So now we have to apply our rule about a quotient being raised to a power, and we said it's almost as if we're distributing that exponent. So this becomes 5b, that entire product is squared, so it becomes 25b squared all over a squared. And that is our final answer.